Okay, today's lesson is about how to use a protractor. So a protractor is a curved measurement tool, looks like this, and it's used to measure angles. So in our last video about angle bisectors, we talked about how we mark congruent angles with curves. That curve represents how a protractor looks. So that miniature curve with the angle is representing the curved measuring tool that we use to name or to measure angles with. So the first way is just if the angle is already on the picture. So notice how this angle here is facing to the right. The first thing you want to do is make sure that the vertex of the angle is lined up with the perpendicular line in the protractor. So looking at this one here, let's see, we'll slide it right there. Notice how there's a little perpendicular line. That lets you know if this protractor wasn't here, you would put the vertex inside of the circle and you would line up this horizontal line with the horizontal line on your protractor. Since it's already drawn, we're just going to kind of ignore it. So the first thing that you're going to want to do is follow the horizontal line. So this horizontal line goes this direction. So you follow it to the end of the protractor. The next thing you need to do is to decide, do you start with 0 and go up, or do you start with 180 and go backwards? Now when it comes to angles and measuring in general, you always want to start at 0. So you always start at 0 degrees. Because when you're counting, you don't count backwards, you count forward. So sometimes you'll be using the numbers on the outside, and sometimes you'll be using the numbers on the inside. So in this case, we actually are going to start on the inside set of numbers because that's where the 0 is located. So as you follow the 0, you're going to go up to 10, 20, 30, 40, 50, and you're going to continue on until you hit the other side of the angle. And this actually stops at 130 degrees. So the measure of angle A is 130 degrees. And if we were going to classify this angle, this would be classified as obtuse because it's more than 90. Now in this case, I want you to use a little bit of common sense when you're using your protractor. So looking at this angle, you can obviously tell that this is past the 90-degree mark. So if I was using the wrong side of my protractor, it would say the angle is 50. Well, 50-degree angles are acute, and that means that they're less than 90. This is clearly more than 90. So using common sense is going to help check whether or not you're using the right side of the protractor, or the correct side. So let's try this angle over here. So this angle over here is facing to the left. That means that you're going to follow that horizontal line to the left. You still start at 0. So in this case, the 0 is actually on the outside of the protractor. So that lets you know you start and use the outside numbers. This angle ends at 50 degrees. So the measure of angle B is 50 degrees. And this is classified as acute. Notice here we know angles that are acute are less than 90. This angle is clearly less than 90, so an answer of 130 degrees would not be correct. So just being mindful of your answers, do your answers make sense? That will help ensure that you're using the protractor correctly. The next type of example are angles that are not flat on a protractor or horizontal on the protractor. This kind of would be an angle that looks like this. There are two ways to do this. You can do it through subtraction. You could calculate this big angle and then subtract this smaller angle from it to find the distance. Or honestly, what's easier for me to do is I would just count the distance between the sides. If you count the distance between the sides, it's going to help you get the correct angle measure. So from here, from 60 to 70, this is 10 degrees. So I'm just going to count 10 plus 10, 10, 10, 10, 10, 10. 10 times 7 is 70. So the measure of angle C is 70 degrees. And this would be classified, again, as acute because it is less than 90. Let's try the next one. So again, on here, we have an angle that's not laying horizontally on your protractor. So you're going to want to count the distance between the sides. So this is 10, 90 to 80, and then we've got 70 to 80, 70 to 60, 60 to 50, 50 to 40, 30 to 40. So this is actually 6 units. Then this one goes from 30 to 25. So this is actually a 5 unit. So this becomes 65 degrees total because you have to add that additional 5 in. So the measure of angle D is 65 degrees, and to classify, we would classify it as acute. So just a reminder, as you're looking at your protractor, these long bars are separated by 10. These little half bars are by 5s. And then these little tiny bars, those are each 1 degree. So if you're calculating and you're kind of in between, just like on a ruler, the halves are slightly smaller than the wholes, and then the little tiny dashes are the singles. So let's practice actually using a protractor, and one that's not just printed on the page. First, we've got this angle. First thing I would do is make sure that there's a point at the vertex. Then I would pick a line to be the horizontal line. So I'm going to just randomly pick this line. Then, to make my life easier, I'm going to turn my paper so that that green line is horizontal. Okay. I'm going to turn it so it's horizontal. Now I have a picture that looks like that first part. So what I'm going to do here, it looks like my line probably isn't going to be long enough, so I'm going to extend this line out. You want to be as accurate as possible and just kind of extend your ray out a little further. Now I'm going to line it up. So I'm going to make sure my protractor is turned the right way so I can read it. I'm going to put the vertex inside of this dot, and then I'm going to line up this green line with this horizontal ray. So I'm going to line it up like this. Notice how I am not lining it up like this. Yes, the dot is in the center, but this line is not matched up with the horizontal line, which is bad. So you want to turn it so it lines up. Okay. So you want to be as accurate as possible. You're going to follow that ray this direction, and we're going to use the inside set of numbers because they start at 10, or at 0 technically down here. Then they move up to 10, 20, 30, and so on. So I'm going to start, and I'm going to follow my ray up, and I end up at the 90-degree mark. Notice how 90 is written large. That's because no matter which direction you're going, 90 is in the middle up top, and 90 would be in the middle on the bottom. So to measure this, I've started at 0, I've gone up, and I stopped when I hit the other side. This angle is 90. Instead of writing 90, I'm going to use the geometric symbol for 90, which is a box. It's located in the corner, and I'm going to classify this angle as a right angle, okay, because it is actually equal to 90 degrees. Let's try one more. So here is the next one. When I'm turning my paper this direction, it's slightly crooked. So I'm going to turn it, and I'm actually going to make this line my horizontal line. The next thing I'm going to do, I'm actually just going to flip my protractor over. I can measure it like this. If that bothers you, you can always turn your paper around. So let's see, if I turn it, now it's horizontal. So I'm going to line up my vertex inside of this dot. I'm going to line up the horizontal line with this horizontal line. So I'm going to make sure that this is lined up and that my protractor lines up with that horizontal line. Next, I'm going to follow this way, and when I get over here, notice how it's not lined up. That lets me know that, hey, my line is not perfect. I need to fix that. So let's see. There we go. Now it's right. Looking up here, I notice, I need to kind of extend, so I'm going to pause for a second. I'm going to extend my line out just a little, and then I'm going to go ahead and organize. So what I'm going to do here is I'm going to line up this piece, and I'm going to go ahead and set up the dot inside of this ray. And then I want to make sure that it's still lined up over on this side, so I'm going to go ahead and shift so it's lined up. Then I'm going to go ahead and start. So I'm going to start at 0, and I'm going to continue up. So I'm using the outside set of numbers here because the 10, the 0, 10, 20, those increase on the outer portion. So what that means is I can't use those inside set of numbers because those inside set of numbers start at 180 and go backwards. So 0, I'm going to continue all the way using the top. I hit to 20, this is 25, and I'm 1 bar past 25, which would be 126. The 5 bar kind of ends here. So that would mean this is 1 unit over. So it's roughly in between 126 and 127. Use your judgment. I'm just going to call it 126, and this angle is obtuse. So again, using a protractor is as easy as just lining up your horizontal line and always remembering to start at 0. So when we come back to the beginning, looking at your picture, you start at your vertex, you extend your horizontal line out, you always start at 0. If you start at 0, you will always start at the right location.